Good afternoon. This is Eric Mucklow. I'm the host of your Sustainability and Energy webinar series from the headquarters of the U.S. Army Corps of Engineers. We are recording this session, which would be available for playback for your colleagues that may have missed it. Today we have Stephen Cosper. He's going to present to us on net zero waste. The webinar will discuss the Army's net zero program, waste management strategies to achieve net zero, and CERL's, that's the Construction Engineering Research Lab, net zero planning tool. Steve has a BS in civil engineering from the University of Illinois and a master's degree in environmental science from Indiana University. Since 1994, he has worked as an environmental engineer at the U.S. Army Construction Engineering Research Lab in Champlain, Illinois. His projects and interests include solid waste management at Army installations, building deconstruction, contaminants in construction products, waste energy, and infrastructure assessments. If you are interested in earning continuing education units, you can download a quiz from our Sustainability and Energy website. There's also a link on the web links section on the right-hand side of the screen, as well as the link there on the main slide. Email those quizzes with your answers to Lindsay Pruitt at the email address shown, and she will see to it that you get credit. The quizzes are done in blocks of 5 presentations. So with that, I will now turn it over to Steve Cosper.
Good afternoon, everyone. Thank you for calling in. As Eric mentioned, I'm going to talk about the Army Net Zero program broadly, then discuss the what I call sort of the big 4 waste diversion options and opportunities to try to strive towards net zero waste. Then I'll talk about a new planning tool that CERL is developing to try to integrate energy, water, and waste diversion and net zero planning. Catherine Hammock, the Assistant Secretary for Installations, Energy, and Environment, began the net zero program about 4 years ago with the purpose of kind of fostering this net zero plan and ethic in a host of or a select group of installations to start with. And here on this screen is sort of the working definitions for net zero in each of the 3 media areas. So we talk about net zero and you talk about energy. That's something you could kind of grasp pretty well. So you are producing as much energy within the fence line as it uses. So your net consumption is 0. Water is a little more hard to grasp, but you are essentially having 0 net consumptive use within the boundary that you defined, and it could be the same watershed or within a particular aquifer system, something like that. But it's the net zero consumption of water. It's consumption of a resource. Waste is a little bit different because the term net doesn't apply quite so well to waste. You could think, well, we're putting waste in a landfill, but maybe you could think, well, we're reusing materials or perhaps buying recycled materials. Possible, but I think what it really comes down to is 0 landfill being our most straightforward working definition. So under Ms. Hammock's net zero plan, the original idea was to select 5 installations each under energy, water, and waste to kind of be the champions, be the first to adopt a set of practices to drive them to net zero in each of these areas. As it turned out, the response was pretty good, and we selected 6 for each of the immediate areas and 2 installations that would be all 3 together. I was part of the group that helped rank and prioritize which installations we wanted to start with. Um, and the for the honor of becoming a net zero installation, you got the attention focused on you. I guess I think of it from the aspect of someone in a DPW at such a place. You have the attention focused on you. You have some assistance in terms of technical assistance from outside agencies or researchers. Um, there's there's not any explicit funding that goes along with this, other than perhaps end of year funding or project funding. Perhaps you might get higher priority for funding for a specific project that helps you towards net zero. But I would say that probably the best benefit so far is that when we were allowed to have conferences, we had annual meetings where people could share information, um, uh, tricks of the trade, so to speak. We do have, but we still have monthly calls where um, one installation or 2 would present kind of their progress, what they're doing, what they're up to, ask questions, um, try to get advice from others who have similar issues. But I think another benefit to the visibility, Ms. Wanda Johnson is the person in Ms. Hammock's office that leads the net zero waste group. The benefit of this visibility is that suppose there's another outside agency that deals in waste material, touches waste material or the generation in some way. So it might be DLA on recycling issues, or the commissary, or AFES, for example, potential waste generators. Well, if there's an issue perhaps in common with several installations, uh, then Wanda can go out and get someone from the headquarters of that agency to come and get a response. So there's a little bit more, I guess, priority, um, uh, and effectiveness in working within this larger group. The bottom bullet there is a list of the current net zero waste installations. Um, so it's sort of a range. Most are, see, Bliss, Carson, Hood, Polk, and JBLM are sort of standard big troop installations. Dietrich is a small, um, relatively small medically focused installation. They do have their own incinerator there at Fort Dietrich, but it's the main reason it's there was, of course, was to deal with medical infectious waste. But they also burn in parallel regular mixed MSW. Fort Hunter Liggett's a growing um, reserve installation, and we have one over in Germany. Um, and it's kind of interesting. Of course, the Germans have completely different systems than we do. Everything is either composted or goes to waste to energy, and there's very specific laws about returning and taking back materials, consumer materials. Um, even leading up to and prior to the net zero program, there were a set of laws and policies um, guiding us towards that, including the Army's adaptation of LEED standards for MILCON. In addition to that, the DoD sustainability plan, which is in turn response to executive orders, calls for 50% diversion of municipal solid waste and 60% diversion of construction materials. So that's a pretty definite goal there. But in addition, just recently, Ms. Hammock's office has come out with a new policy saying, it's not just you pilot installations, but we want everyone to strive for the net zero goals. Part of this is part of the initial setup or ideas behind achieving net zero, especially in the area of energy, is try to encourage um, uh, investment from the private sector. Uh, for example, there might be you could build a small power plant on an installation with private capital, but the government or the installation agrees to buy back that power at a specific rate for a specific time. That would be like a power purchase agreement. Energy savings performance contract an example would be um, a company would come in and do energy retrofits or upgrades to a set of buildings, and then the company gets paid back from the delta in energy cost that the installation would have paid had they done nothing. Um, Again, for waste, that the analogy isn't really good. The Although I could see one possibility might be something like a waste energy facility um, where the installation agrees to uh, put so much waste into it over a given period of time and then buy the power purchased back. But nothing like that has happened to date, but I'll mention a little bit later. There's a few things in the works. I want to talk about waste data. The solid waste annual reporting system is what the Army uses. Uh, Axum is actually a proponent for this to collect data from every Army installation that generates more than 1 ton of waste per day, and they it, have to report in some detail, um, quantities of waste and recyclables broken down in many categories, and then to what um, offsite facility for disposal or recycling. The table here gives the FY13 roll-up of all those figures. Um, it's uh, pretty reasonable data in terms of getting an overall picture of what's going on. There's some known problems, like, for example, the GOCOs sometimes don't report. Um, Reserve facilities, um, it's hard to get a handle on that because there's so many throughout the country, um, and there might be one headquarters agency person who's trying to coordinate all that. So even if they have for their command, their regional command, they might have a good total number. It's not broken down um, by location. Um, I, I think that the data of SwarWeb might be numbered as the Army is trying to go with more a corporate database system for all facilities and utilities uh, reporting and tracking. This is what we have right now. Um, Based on the numbers here, uh, you can kind of see the level of magnitude that each of these materials contributes to the overall waste stream. Um, C&D materials do tend to be higher across the board, at least 50% by installation of the total. Um, for a given installation, just for scoping order of magnitude, you might have tens of tons a day of municipal solid waste. So what I'd like to do now is talk to you about what I would consider the kind of the big four, the um, areas where to achieve net zero that we need to focus or refocus attention to really have a hope of getting there. Um, as you saw in the previous slide, C&D materials are still um, quite a large proportion of the total. Um, oh, excuse me, let me go back that slide just for a moment. The column on tons recycled under MSW, um, so it's less than 50% recycled. I think that's probably reasonable across the Army, although many individual installations are above that, and so we need to kind of, as part of the reason for the net zero program is to spread the good word and help others come up to the rate. Under the row C&D materials, this says well over 50% recycled, as reported. I'd have to say I'm a little skeptical of that number total, and it might be just because I'm jaded and I've seen huge quantities of waste go into landfills on Post and other places from demolition projects. That makes me a little bit skeptical, but we are making slow progress in uh, doing a better job of tracking C&D waste and promoting diversion, over the years. And Jeanette Feast from Seattle District, I think, may be on the line and can talk a little bit about that at the end of my slides. Okay, back to C&D specifically. Um, Again, thinking about it in the context of someone who is a program manager at an installation, say the waste manager in DPW, um, the actual construction projects are funded by, different groups, different agencies, different funding streams, and certainly different contract actions. So each of those contracts would have their own specifications for waste planning, waste diversion, um, and so for someone trying to do some kind of holistic waste planning, uh, either either just planning or setting up some kind of installation-wide diversion strategy, it's very hard to rein in um, all those different activities that are together. Um, some of the uh, some of the options um, would include a waste plan, and the Unified Facility Guide Specs. There are examples. There's um, the need for a waste plan is clearly spelled out, as well as examples of how to do that and what should be in a waste plan for specific jobs. But in terms of the technology of what can physically be done with construction materials, one very straightforward thing to do is just take the materials commingled together to an offsite C&D MRF. That's in MRF is Material Recovery Facility. These are common more on the coasts, not so much in the center of the country. The picture on the bottom right is at a site outside of Raleigh-Durham several years ago. But basically, for a mixture of heavy equipment, automated sorting, and hand sorting, they can pick out really the main contents of the main constituents of mixed C&D materials. So concrete, wood, metals are all separated fairly efficiently. Certainly can be done fairly efficiently. The drawback to that is if when using a site like this, depending on the situation, you may not be always assured of what's really being recycled, or are they just passing through, maybe picking out the best stuff, the metals, and just landfilling the rest of it. Um, some of these operations actually have their own landfill, so it's a little mysterious. However, I will say that the C&D Recycling Association is a national trade group that promotes these kind of businesses and capabilities. They are developing their own certification system, such that if you were to take materials to one of these places, um, you know, you'd be pretty well assured that what they tell you the material is going, you'd be pretty well assured that that's in fact where it is going. That certification program is um, just started out last year, I believe, but certainly I could. I know the head of that organization. We could investigate further for a specific site if you're interested in. The second obvious thing to do to promote C&D diversion is crushing concrete on site, concrete or asphalt concrete. Um, Now, it's a little misleading because diversion numbers are based on weight, and so concrete's very heavy. So recycling a modest amount of concrete goes a long way towards diversion goals. Um, one way this is done that we've seen at Campbell, Bragg, Hood, and I'm sure others is that they would direct contractors to bring concrete instead of to a landfill or to the on-site landfill, to stockpile it at a central location, could be adjacent to an existing landfill. Um, and then periodically, the DPW would contract for a crushing service to come in um, and crush the accumulated materials. Uh, and then that concrete could be crushed to the specification of DPW, uh, range control, uh, etc., for whatever purpose they need. It could be parking lots, could be fire break, riprap, um, and uh, so in that case, doing it that way, you are avoiding the landfill cost uh, for the concrete, as well as you're avoiding the cost of purchasing virgin materials from outside the gate. But of course, there is a cost of the crushing. Um, Early on, some installations were talking about buying this equipment, but I think even in the places where there's a lot of work going on, and as we know, uh, Milcon activities are starting to decrease. Um, Probably doesn't make sense for the installation to buy this equipment, but rather contract for the service. Um, and then the final item would be deconstruction of wood and metal frame buildings. Um, when I first started looking into construction material diversion um, 15, 20 years ago, the elimination of World War II wood buildings was very high on people's radar, very important topic. Um, and the FRP program at Huntsville was started in, in response to that to help remove these facilities. And so here at CERL, we did a lot of looking at methods to remove these buildings quickly, deal with lead paint issues, and reuse the material. Um, so that's possible, um, uh, but this picture shows actually a mechanized trial we had done at Fort McClellan, um, trying to or minimize the time it takes to remove these buildings from the site footprint. And we found methods that could work, but I think that the quantity of these buildings left in our inventory is getting low. So it's probably less applicable nowadays. Certainly, there's light framed semi-permanent buildings, light metal frame buildings that are very conducive to disassembly and reconstruction, if not simply disassembly and recycling the metal. So C&D, number one priority. Click the button. Okay, compost or organics waste management would probably be my number two candidate for trying to divert. Over the last couple of years, many installations, especially the net zero sites, have really been looking into this, um, trying to look at ways of diverting food waste and other clean organic materials from the landfill. It's problematic. It's hasn't been addressed terribly well across the Army to date. Um, uh, Food is a good example. There's a lot of it generated in dining halls, but little effort to separate it. And food being wet, it's very heavy, so that if we could compost the food, that would go a long ways towards the diversion goals. There's really a range of technologies applicable depending on what the material is and the quantity of it and some other considerations. Um, you can do large scale, low tech, like windrow composting, which is great. It works for really a lot of different materials. Um, could be in many different combinations. The top picture there is a Scarab windrow turner, originally purchased at Fort Sill, and now it resides at Fort Hood. Um, but that can move a lot of materials all at once. The downside of uh, outdoor windrow composting is that you need a large area to do it, and possibly there'd be stormwater permits or waste management permits required. But the contrast to that, smaller scale, the bottom picture there is an enclosed um, in-vessel composter at Fort Myer that they were using, demonstrating for food waste. It's just a standard roll-off box that has a kind of a greenhouse affixed to the top of it, and then there's an automated mixing auger that travels back and forth, mixing the material. It works great. It's the benefit of it is it can be done close to the cantonment area. So, for example, you could have this right next to a DFAC. You could set one next to the dumpster, and so instead of the workers hauling food to the dumpster, they could just haul it and deposit the food right in this device. So it wouldn't be any extra work. The downside is these things are not cheap. Although this one I think was about 150K altogether. And the volumes that they can handle in that in that small package are not great. A ton a day, something like that, or if that much, maybe even half of that. Whereas if you're doing open windrow, out in the ranges somewhere, you're essentially unlimited in your capacity. No matter what you want to do, you need to strike a careful balance of the materials present and the mixtures so the compost action works correctly. For wet materials, and food would be a leading candidate for that, really you need about a 50-50 mix of food and wood chips. The wood acts as both a carbon source for the microbial decay action, but also as a bulking agent, meaning it increases porosity and allows oxygen to get into the mix. So in planning such an operation, you need to line up not just your waste that you want to treat, but a wood chip source as well. If you're composting just land clearing debris, brush and leaves and grass and and wood chips, probably just that material by itself would work very well. We've done at CERL done a fair amount of work recently on this topic. We did a feasibility assessment for Fort Polk, looking at all the organic waste streams and the size of compost yard they would need. We did a technology study for Wanda Johnson just on the various compost technologies and what's applicable under what situation. And currently we're looking at a decision tool for INCOM, trying to say under what, for a given installation, under what circumstances would a given technology be applicable. And then the next of the big four would be recycling, just standard recycling. And the reason is that still we're seeing a lot of potentially recyclable materials in the trash. The top picture is an old one, but it's at the transfer station at a big installation, and just dumped at the transfer station was essentially a load of straight cardboard. So that's still going on, and doubling down on standard recycling is kind of the next thing to hit. There's a new public law requiring office paper recycling at all federal facilities. So we have that. We have to do a better job at that, regardless. And the other big consumer, other recyclable stream would be mixed consumer materials. And so that, newspapers, magazines, junk mail, beverage containers. And the trend in industry and in municipal service has been to collect this all in a commingled stream. So at the installation, instead of having one small dumpster for newspaper, one for glass, one for number one plastic, number two plastic, etc., just collect that all together. And the theory is that if it's easier for people to participate and contribute their stuff, then we'll get a higher percentage of the total waste stream collected. Um, Now, to do that, then to process that, it has to be sorted out in a fairly sophisticated recovery facility, and usually those are associated with larger cities that have commingled curbside programs. So you have to have access to I mean, within a couple hundred miles anyway, of a MRF at a larger associated with a larger city usually. We're doing a study at Fort Leonard Wood, Missouri currently to try to see if that makes sense. Um, One of the problems I hear about recycling is that, well, kind of coordinating the collection, the generation and collection of the materials inside the building, inside the office space, with the collection, outside the building. So there has to be a coordination with the janitorial staff, as well as the hauling contractors, just to make that happen. And the DPW, waste manager, contract supervisors have to help with that. Finally, of the big four is waste to energy. Um, net zero waste means means zero waste to the landfill. I'm afraid we're never going to really get there. I mean, we're never going to be rid of ourselves of mixed trash where there's just nothing to recycle. It just mixed, contaminated, wet stuff. So there's always going to be a need for that final disposal. Um, Waste energy facilities currently in the United States, the scale at which they operate is at major municipal, major metropolitan scale. The picture on the top there is a big facility outside of Boston that takes in hundreds or thousands of tons a day, whereas our installations might be tens of tons a day. So it's a different scale. Um, the big sites use mass burn, incineration to drive a turbine, make steam, drive a turbine, make electricity. At that scale, that's what they need to make this viable. Um, in our case, our installations are smaller. Electricity is often inexpensive. Landfill is often inexpensive. So commercially, it doesn't make sense, or even technically, really, at our scale for right now. There is potential to work with the host communities and outside agencies to perhaps site a joint waste energy facility. So Fort Bliss is talking with El Paso, and they issued an RFP last year looking for interest from companies to site facilities for both the city and the installation. Joint Base San Antonio recently commissioned a study of all their waste streams to see if the quantity and composition would be favorable for a joint waste energy facility in San Antonio. Dyess Air Force Base, I heard, had issued a similar RFP looking at trying to do a joint facility with their host community. In terms of diversion goals, waste energy may or may not count depending on who you talk to, what the specific goal is. It would count towards net zero in terms of the net zero program. It would probably not count for the diversion goals as stated in the SSPP, but I think nonetheless it has to be a portion of the makeup eventually. There's a bunch of smaller scale waste energy technologies under development now for contingency basing, and the reason there is obvious that power is expensive, waste handling is problematic, and it's worth it to invest in the R&D as well as the just the development of something to solve the problems in contingency. I'm working on a project. The bottom picture there on a gasification system puts on the order of 1 to 2 tons a day. So in between 1,000 tons a day and 1 or 2 tons a day, we have the technology gap. I'm hoping eventually that these smaller scale technologies will be able to be scaled up. Next, I'd like to talk about the net zero planner system that we're developing at CERL. Um, so not only you have the potential waste technologies that I mentioned briefly, but you also have analogous things for energy conservation, water conservation, and these technologies do interact. For example, um, one of the containerized composting system I showed takes some electricity to run as well as a little bit of water. So there are these interactions, and the idea of our net zero planning tool is to help someone figure out what is the optimum set of conservation measures to maximize your like waste diversion or energy savings or minimize costs. This is a web-based tool that we're developing that incorporates many different models. So there's energy models for buildings. Um, we have weather models that can be applied for a specific location. There's an EPA water model on water use distribution and usage within a building for different fixtures. And we have waste models that we're developing on construction materials as well as waste generation within specific building types. So all this is going to be rolled up together, all these different models, and applied to a specific location, a specific installation, or a specific subset of an installation, a specific cluster of buildings to predict the uh, consumption at those buildings and give suggestions for diversion. Currently, we're working with these 5 installations to demonstrate this system and kind of a beta site for the energy portion of this planner, which is actually the energy portion is very well developed. We're just working on the water and waste piece right now. We're actually using these sites to kind of collect information to feed into the planner to sort of prorate to check if our models are correct. So we're collecting actual information from these sites and seeing how the model predictions line up. Um, so the information and the planning factors are based on, in part on, the predictions are based on easily identified GIS GIS inventory information. So you have building size, building function, building age, for example. So we could select um, um, the subset of buildings and say, oh, well, we expect the performance of this building to be, X for, water consumption or energy consumption, just based on those factors. And on the waste side, we're developing waste generation factors for um, uh, by building type and by by function and by size. So um, a DFAC would generate X pounds of waste per day per square foot or per meal served. So that's the kind of factors we're putting in this. And then the idea is that you could, not only model what you're doing now, which is nice, but the real power is saying that, okay, at some point in the future, based on projected MILCON, projected FRP, projected realignments, what do we expect our base to look like? And given given what master planning tells us, then we could predict the uh, net electric load, the net water consumption, and the net waste generation based and compare that to the current. Again, just based on some fairly simple planning factors. Um, and this is on a per building basis, mainly relating to energy, but we look at the uh, current performance of the building, um, simulate uh, the occupancy, the electric loads, and the weather profiles of that building for an entire year, and then come up with a set of energy saving technologies or upgrades that could benefit that particular building. Uh, and so here's an example for one given building. You start on the left side of the graph, and that's where you are to start with in terms of energy intensity. And as you apply more and more technologies going to the right, the energy intensity drops. Uh, and you could see, just kind of how far you want to go, what energy savings that you want to achieve, and that'll tell you in what order would be most efficient to apply these different energy saving techniques. So the past couple slides were just about a given building. So if we apply this analysis to the entire installation, um, doing upgrades building by building, may not be the most efficient thing. So that we have a module called NZI Opt in the planner that looks at all these things, meshes it together, and picks out actually um, ideal clusters of buildings where perhaps you could put a small cogen plant to serve multiple buildings, for example, such that uh, the net savings would be beneficial um, uh, as opposed to doing eaches at each building. So another example for energy might be, instead of putting solar panels on roofs, you might have a large solar farm somewhere else, and then that goes into the grid. And as I mentioned, we're currently integrating the water and waste uh, factors and diversion techniques into the net zero planner. That should be ready for testing at the end of this FY. Um, and the idea is that we'll have the analogous optimization and planning factors to the energy side. Um, it's been a bit of a challenge looking for waste generation, by building type, and we have a few sources, um, as well as doing some dumpster diving to kind of prove it out. And that is it for me. Thank you very much. Um, is Jeanette on the line? And did you want to say a few things about waste management and waste reporting in the MILCON context?
Yeah, hi Steve, thanks, I'm here. Can you hear me?
Great. I can hear you.
Okay, great. Well, thanks everyone. My name is Jeanette Feast, and I manage the Energy and Sustainability Program for Northwestern Division, and wanted to just take a couple minutes here at the end and highlight, at the beginning, Eric mentioned a little bit about the Centers of Expertise for Sustainability, and wanted to highlight that Northwestern Division, we have Centers of Expertise around the Corps of Engineers. We're here to help projects and help teams as they're working on different technology areas. And one area that Northwestern Division has been assigned is net zero waste. And so Steve has walked through a fantastic presentation. Steve is our counterpart that's working at the research lab. So he's walked through a fantastic presentation for us, showing all the different components, highlighting the 4 different areas that are the big waste areas to be considering when we're looking at reducing our waste. And so a few things that I just wanted to highlight or share as we're getting ready to go to questions and close up. Just a reminder that waste diversion is a requirement on all of our projects and at all of our locations. So whether it's a Army or a Reserve, Air Force, Navy, and other projects, it is something we need to be integrating into our projects, both SRM and O&M projects, as well as MILCON and new construction. But also there's opportunities, as we've seen, as Steve has talked through, there's opportunities to support the installations and support our customers in other areas. So for customers who are grappling with how to handle all of the food waste through composting or other alternatives, Steve highlighted that there is a great great collection of resources that the net zero waste installations and others join monthly on a conference call. And so I know that Steve participates in that. We've got other folks from Northwestern Division that participate in that monthly conference call, and it's a good opportunity for installations. If there's folks on the line that have questions about some waste challenges and issues that they're having, that's a great tool and resource for people to reach out to. But within the region, we too, NWD, are here to help people out. So if you've got questions, if you have a customer that comes to you with a specific need, then we can help connect you with Steve. We can connect you with other installations who have gone through that before and help you figure out how to most effectively support your customer. So there's lots of good resources there. Another thing Steve talked a little bit about, it is important to know that the resources for whether it's C&D waste diversion or other types of waste reduction do vary by region. So he talked about that we've got different capabilities on the east and west coast as compared to the middle of the states. And so that is something to be aware of. We have some resources in NWD where folks have started to look and see how does that impact our ability to reduce our waste and to divert waste. So if that's something, if you need a market analysis, that's something that we can help out with and put you in touch, because that often is one of the biggest hurdles to overcome, is making sure we're aware of what markets are out there and then taking advantage of those markets. So wanted to just highlight a few of those things. We do have, the last thing I want to touch base on is that we do have a website that we have available for the centers of expertise that goes addresses each of the different centers, so not just the waste center, but we've got a website that addresses each of those. Those websites are going to be migrating here in the next couple of months. But if you have questions about that or want to see some of the information that we've got posted there, you can contact me or others and we can get you that information. So I just wanted to let folks know that we are here to work with you and help you as you help your customers in their efforts to achieve net zero waste. So with that, I'll turn it back over to Eric and Justine if you guys want to moderate questions.
Net. This is Eric Mucklow again. I will take questions. We have the Q&A block on the right-hand side of the screen that I opened up, and at the bottom of that Q&A block there's a little text entry box. You can type in your questions there and submit them, and they'll show up on my screen. They won't show up on your screen. And then I will read the questions, consolidating any redundant questions, etc. I'll read the questions for Stephen or Jeanette to answer verbally, so that it gets on the recording and everything. Sometimes it's hard to read the video text. So first off is if there are any questions. I don't see any coming in yet. Give people a chance to type here. And you see Stephen Cosper's contact information on there. I assume he's also on the global email address list. I'm not sure about that.
Correct.
But it was a very good presentation.
Thank you. I just want to say thank you for Jeanette for speaking up. In addition to the Net Zero CX at Northwest Division, there's a Waste to Energy CX specifically at Fort Worth District. Okay. So it's kind of
here's one.
Two sides.
One of our problem streams is treated wood that cannot be used in waste energy. What is your thought about treated wood? I assume he means the old arsenic laced wood for pest control.
Arsenic treated wood, that's a difficulty because you can't, it would be undesirable to try to compost that. One, because it wouldn't degrade because it's treated, but as well as just the arsenic is not a biodegradable contaminant. So I'm afraid that's probably going to be a landfill item unless you could have you're near an incinerator that is especially permitted that could allow that as a fuel, perhaps in a very small proportion to what they're currently permitted for. If it's creosote or PCP treated wood, again, that's not something that could be handled on post in terms of a compost operation. but that could, again, that from just an energy standpoint might burn very well, but again, it would have to be somewhere that's specifically permitted to handle that material. So yeah, sorry, it's not great options for either one, but um, yeah, that's it.
Okay. I haven't seen any more questions coming in. 7 minutes to go.
If whoever answered that or
Okay.
asked that question would like to send me a note, I could look into it a little further. We have a researcher here that does a lot of work with the railroad industry, and of course that's a huge problem for them is disposing of the treated ties.
What about creosote treated wood? Speaking of that, I know creosote is a carcinogen, but is there anything to be done with them?
That's well, that goes along with just what I was saying. Creosote, you know, from just a mechanical, physical aspect, would burn very well in a waste energy facility, but that's not something that you would uh, you want to deal with on post or compost. It would have to go to a waste energy site that's specifically permitted for it. Uh, but again, like I said, there's other industry groups that have had to deal with that. Utility companies or the railroads um, um, have uh, have tried to address that. So I, someone want to email me, I could try to follow up.
I remember a long time ago I saw some research into CMU blocks, concrete blocks that were made not from fly ash aggregate, but from wood chip aggregate with the cement basically mix encapsulating them. I don't know if that would be something that they could do, um, or if that would be something that wouldn't want to be handled or cut. But there is on the bottom in the file share block, I have a PDF of the presentation that people can click on and click save to my computer if they want to download it. Again, we have the sustainability and energy um, website link. Oh, and I have another question coming in from the same person. Any thoughts on liquid composting? We tested one from Fort Hood loaned to us by USAEC. Mixed results here.
Um,
Liquid composting.
I believe that is talking about the uh, oh gosh, I'm not going to remember the name, but it was a digester, a small digester system that would be installed in a DFAC, and food waste is placed in there, and with a little bit of water, a little bit of heat, it's essentially the food waste is degraded and liquefied, um, and then it just goes into the sanitary sewer. So you are diverting waste from landfill. That's true, but you're also putting an additional load onto the sanitary sewer. Now it's at an energy cost and at a water cost to do it. Um, I would say in most cases that some kind of composting system would be an overall net benefit over the uh, over that small digester. I'm sorry, I can't remember the name of it right now. But there are some cases where having an additional organic load down the drain might be beneficial to the wastewater treatment plant. Uh, but that would all be very site specific.
Would that be an anaerobic type digester or something, or?
I don't believe it was an anaerobic digester because it's not producing any kind of gas. It was just strictly
Right.
a liquefaction of organics.
Okay, we have a couple minutes to go and one more question. Can you speak regarding what is considered waste and what is repurposed? For example, if burned waste releases CO2, I assume she means for burned in a waste energy plant or something like that. If burned waste releases CO2, how is that handled in the net zero equation?
Thing. Um, if so, for any of these sort of analyses, where you are diverting of waste, where you're recycling waste, um, certainly in our calculations in this net zero planner exercise, you could you could go down the rabbit hole a really long way, but you have to, cut it off somewhere. And in our case, we're just looking at, essentially the fence line for most things. Um, if you are, if you're burning a waste and you are releasing the CO2 into the atmosphere, no, in all cases I'm aware of, we're not tracking the mass of the carbon going into the atmosphere for sort of for the waste accounting purposes. Burning waste does not um, count as diversion. On the good side, it would be. Um, I'm sorry, it's diversion in the context of the DoD sustainability plan. That would just count as disposed or same as landfill. In the sort of the net zero waste, uh, if you're taking net zero to mean zero landfill, then yeah, then it would be then that would count towards diversion in that regard. But no, tracking in terms of CO2 would not be something we would want to try. I think the first part of the question might have to do with what's the definition of waste. Um, I mean, waste is basically anything you say it is by declaration. Uh, but in terms of a repurposed item, if you were to salvage something out of a building, or say you are saving furniture, reconditioned furniture out of a barracks remodel, something like that, then that would not be a waste. That would not count in the numerator or denominator of your waste diversion.
Okay. One thing that's come up in some of my prior engagements was talking about reuse being like if you reupholster your couch and it's still a couch and it's still being used a couch. But if you repurpose, say, a table and you cut the legs off and make it a bench, that's basically a repurposing. That's probably not a very good example. And then recycling would be where you take something and break it down into a commodity material like glass melted down, steel melted down back into steel, what have you. And then of course diverted waste would be basically referring to anything diverted from a landfill, because not just the carbon gases and greenhouse gases and things are a problem, but also the land that is being taken up and the leaching into the groundwater and all that from landfills. So they're kind of different agendas in a lot of these equations and what they're looking at. So I don't know. Do you concur with that kind of brief description, or you want to add or
Oh yeah,
comment on it?
those are good definitions. One of the things I've run into, um, I say especially with regard to construction products that that have lead paint on them, for example. When does something become a waste? And if, say, you're salvaging something from a building and you need to do some kind of process to it to make it salable, well, uh, regulators might look at that differently. It's really very subjective. And once something magically becomes a waste, then you have a whole host of permitting requirements and disposal requirements come into play. But you know, for most things that we deal with, a waste is a waste if the the default position is to chuck it in the dumpster, and you're trying to do something else with it. So it's thankfully usually pretty straightforward.
Well, I left one item off of my list, and that was things that are waste avoidance. And that would be if you're getting a whole boatload of widgets in that all come in big, thick, bulky blister packs of plastic, and you make an arrangement with the manufacturer not to have them in the packaging, but just delivered in boxes or something like that of just simple sleeves altogether. You're avoiding waste creation, and that can be counted for something else. But we are at 4 past the hour, so we're gone a little over. I just basically want to thank you and Jeanette for joining us. Again, Stephen Cosper, environmental engineer at the Construction Engineering Research Lab. Email on the screen and, of course, in the downloadable presentation as well. I will now cut off the recording, and I'll leave up the screen here if people want to follow those links or download the presentation in the file share section down there on the right. Again, thank you very much.